Hey, welcome back, Algebra 2 students. Today we're looking at asymptotes. So we have two different types of asymptotes. So we are looking at the first one. The first type is vertical asymptotes. They occur at values of x that make the denominator 0. They're vertical lines that the graph approaches but never crosses. So if we look at this one, x equals 1, right, because it's crossing through the x-axis at 1, would be our vertical asymptote here. So these lines would get ever and ever closer to the asymptote but never cross. Alright, for horizontal asymptotes, what they do is they show us end behavior. And end behavior means what's happening as we're approaching infinity and negative infinity. So if we go ever and ever further to the left or to the right, the horizontal asymptote shows what value we're approaching. One note here is that the graphs can cross horizontal asymptotes. So when you do certain trig functions, you guys are not going to really see too many graphs that cross the asymptotes in Algebra 2. But if you guys do go to calculus, then you will see cases where the horizontal asymptote is crossed. Alright, so to find vertical asymptotes, pretty easy. We're going to set denominator equal to 0, and then we're going to solve. For horizontal asymptotes, we have to follow a few rules. So if we look at the first one, it says if the degree of top is greater than degree of bottom, then there's no horizontal asymptote. So let's say we have something like x squared minus 1 over x plus 2. Alright, so what the degree means is that we're looking for the highest exponent on one of our variables. So notice that our degree on top is 2. On the bottom, we have an x, but no exponent. The exponent on any x without an exponent, we would assume to be 1. So notice for this one, the top degree is larger than the bottom. So this example would have no horizontal asymptote. No horizontal asymptote. There will be an oblique asymptote for this one, but we're not too concerned with oblique asymptotes. So the next one, it says if degree of the top is less than degree of the bottom, then the horizontal asymptote is y equals 0. So let's say we have 2 over x plus 1. So the top, we don't have any x's. This would be degree 0 on top. On the bottom, we have an x plus 1. This would be degree 1. Right, because we said that if we don't have an exponent on it, it has an exponent of 1. So the top is definitely less than the bottom. So our horizontal asymptote would be y equals 0, which is the x-axis. Okay, and then on the next one, it says if the degree top is equal to the degree of the bottom, then the horizontal asymptote is the lead coefficient of the top over the lead coefficient of the bottom. So if we had something like 2x plus 3 over 4x minus 1. Notice that our degree here is 1. Our degree here is 1 as well, so the top and bottom have the same degree. All we do is take the lead coefficient, so that means whatever our number is with our x, or with the highest degree term, in this case we have 2 and 4, then we just take the 2 over 4 and reduce it, so we get 1/2. So y equals 1/2 would be our horizontal asymptote, meaning that we'd have a horizontal line passing through 1/2 for our y, and then our graph would approach that on both sides. Okay, so let's do some examples here. The first one is an Alex. Alright, so this is one of the things that we need to answer a bunch of questions about the same graph. So it says the graph of the rational function f is shown below. Assume that all asymptotes and intercepts are shown and that the graph has no holes. Use the graph to complete the following. So it's asking us, where is the vertical asymptote? So if we look at the line that's going straight up and down, we can see it's at -1. So we're going to say x equals -1. Whoops. Now if we check our horizontal asymptote, the line that's going across, it looks like it's at -2. So we're going to say y equals, it's crossing through a y-axis, y equals -2. And it says find all intercepts. So if we look at the x-intercepts, it crosses through the x one time at -3. And it crosses through the y at -6. Now it's asking us to find our domain and range. So when we do our domain, remember domain talks about x values, right? So we're going to write this in interval notation. And these are all going to be parentheses because we never hit these lines, right? They're asymptotes. So let's bring this down for a little while. So on the left-hand side, we always start with the left. So that we have -infinity, right? It goes on forever to the left. And then it continues all the way to the vertical asymptote. So the vertical asymptote is at -1, we said, right? So to -1. Okay, and then it stops because we have our asymptote at -1. So we need to put our u. And then it starts again from -1 all the way to infinity. From -1. Oops. From -1 to infinity. Okay, likewise for the range, but for the range we're talking about the y values, so we're going up and down. So notice that the bottom part of this graph, it goes from -infinity. Ugh, what did I do there? There we go. So the range goes from -infinity all the way till we hit that line, that horizontal line at -2. And then it starts back up again from -2, and it keeps going up towards infinity. Whoops. -2 to infinity. Okay, we can go ahead and check. Wait, what happened here? Vertical asymptote, x equals -1, correct. Horizontal asymptote, y equals -2, correct. X-intercept at -3, correct. Y-intercept at -6, correct. I'm wondering if this... Oh, no? Am I missing a comma in here? Let's erase this thing. That's the only weird thing I can find in there. Okay, so let's do this again from -infinity to -2. That should do it. Oops. Okay, we got it. Alright, back to the graphing part. So we're just graphing the vertical and horizontal asymptotes for these, which means that we don't have to draw the actual graph. We're going to do that in our next Alex assignment. So we just want to graph where the horizontal and vertical asymptotes are. So let's go ahead and do that. So the first thing we're going to try to find is vertical asymptotes. So we said earlier, if we're finding vertical asymptotes, what we're going to do is we're going to set the denominator equal to 0. So we're going to do 3x minus 9 equals 0. And then we're going to solve it. So we're going to add 9 both sides and divide by 3 so that we have x equals 3 That's our vertical asymptote. For our horizontal asymptote, we're going to compare the degrees, right? So the top, degree 0 because there's no x. The bottom is degree 1 because we just have an x, no power on it. So if the top is less than the bottom, then we know that our horizontal asymptote equals, our horizontal asymptote is at y equals 0. So you can draw your graph. And then we just draw our asymptote. So the horizontal asymptote is y equals 0, meaning it's the x-axis. Our vertical asymptote is at 3. And then we'd be done. So you're just going to plot those lines out and then be done with it. All right, for the second one, okay, vertical asymptote. We know what we're doing here. We're going to make the denominator equal to 0. Whoops. Negative x plus 2 equals 0. We're going to subtract 2. We're going to divide by negative 1. Or you could just switch the signs at that point. And then x is equal to 2. That would be our vertical. And then for our horizontal asymptote, the degree on top is 1. The degree on bottom is also 1. So we know we have to take the coefficients here. So 3 over negative, and because we don't have a number in front of x, we assume it's 1. So our horizontal asymptote is at negative 3. All right, so let's go ahead and graph that. All right, our vertical asymptote is at 2. Our horizontal asymptote, excuse me, is at negative 3. And we just plot those lines out. Okay, a couple more examples here. So this one, vertical asymptote. We're going to do x minus 2 equals 0. I mean, you could do it in your head, right? What minus 2 is equal to 0? That's going to be 2. But for those of us who need to show our work, that's fine too. So x is 2. And then for this one, because our degree on top is 2 and our degree on bottom is 1, this has no horizontal asymptote. So we just graph our vertical. Okay, and then on to the last one. So this one's a little bit trickier because we got to factor the bottom to find the vertical asymptotes, and we're going to have 2 of them. So x squared plus 3x plus 2 equals 0. So it's a quadratic, right? So in order to solve, then we have to factor. So there's no coefficient in front of the x squared, so we have just x and x. And we're looking at what multiplies to get 2, adds to get 3. That would be 1 and 2. So now we're asking ourselves what makes x plus 1 0 and what makes x plus 2 0. So we know that x is going to be negative 1 because negative 1 plus 1 is 0. And then x is going to be negative 2 because negative 2 plus 2 is 0. So we have 2 vertical asymptotes. And then our horizontal asymptote, because the top degree is 0, right? There's no x. And the bottom degree is 2 because our highest is x squared. Then we know that it's going to be at y equals 0. So let's go ahead and sketch this really quick. Okay, so we have two vertical asymptotes, one at -1 and one at -2. And we have a horizontal asymptote at y = 0. Okay, so that's it for today. We're gonna spend another day on this practicing with the worksheet next class. So we'll get good at that, and then the next time after that, we're gonna do the actual graph. So hopefully you guys get really comfortable, because once we plot out where the asymptotes are, then the graphing is not too bad. So I want you to get really good at doing that, so that when we do the graphing, it's pretty easy. All right, good job.